It's such a nice weather outside, and you made a conscious sacrifice to still show up. I appreciate that, and I believe today's speakers also do so. Also, special thanks for Veriff for being such a great host for second time already. Veriff guys, you're awesome. Thank you so much for that. One other small announcement. So today's second talk held by Gleb is going to be super interactive, and he kindly asked you to fill in the pre-talk form. The link's over there, so if you haven't yet, please do so and help him to prepare in a better way. Thank you so much for that. And also thanks to our supporters who support DEVCLUB and make this all possible. And for today's agenda, we have two talks. One by Veriff's very own Madis on system-wide end-to-end testing, and then another one on communication and giving feedback and receiving feedback and you know, talking to people by Gleb, who is a data-driven pitch coach. So this one, as I already said, is going to be super interactive. So buckle up. And enough of myself. I would like to invite on stage Madis. Please greet him with a warm welcome.
Is the mic working? Yes? No? Yes?
You gotta test the back.
Ah.
Can the back hear you?
Can the back hear me?
No.
We got a yes or no.
We'll have to do, I try to use my voice as much as possible. Let me just quickly set up my computer here. Whoop, whoop, whoop. All good here. So, hello, I am Madis. I'm a developer experience engineer here at Veriff. And our mission as the developer experience team is to build tools to ensure that the build, test, deploy lifecycle, like the heartbeat of any engineering team, is as frictionless as possible so that our developers can be happy and that they can deploy with confidence. And one of the tools that we built to ensure that is this end-to-end testing suite that we run for most of our production deploys. So it's like a mandatory deployment gate that all of the deploys go through. But before I even go there, let me sort out a few things first. So first off, we're here at Veriff. And just today, we made this massive change. We decided to change our branding into this. So if you see people around the office with, OK, is this better? So if you see people around the office with that logo on the hoodie, they're not imposters. They are also people at Veriff. Although my slides will all still have all the old logo because I didn't really have the time for that. Secondly, let me also talk briefly about our product, what we do here at Veriff. So we build base infrastructure for trust online. So offhand, you could say that we help our customers meet their KYC or know your customers regulations. So maybe you are opening an account on a crypto exchange, or you want to transfer a large sum over some new fintech bank. We help these companies to verify the users and fight fraud. But that's not all. This is definitely like one part of our business, but there's more. It's not only fintech. You could use Veriff also, like let's say you want to order an age-restricted item over a delivery service, or you want to get access to your work credentials when you've lost them to verify yourself digitally, or maybe you're buying an apartment fully remotely. It's COVID, you cannot go anywhere, but you still want to buy that apartment. So in all of these cases, our product, or we as Veriff, we are on this critical path of that customer. We are somebody in the path of somebody trying to open a bank account. We're in the path of somebody trying to buy that apartment. So we're like a key component of that transaction flow. And to that end, quality is really important to us, to our customers, and finally to these end users like trying to do these things. So how does this work technically? It's been said that we're a bit like Stripe or like Stripe Payments API. Let's say we have these two counterparts here. We have an astronaut trying to do something, open a bank account, and we have a bank. And this bank makes a call to the Veriff API saying that, okay, I want to verify this user. We send back this magic link to this bank that then gets forwarded to this customer where they can go through what we call our verification flow. So maybe they take like a picture of their document, maybe they take a picture of their face, maybe they need to scan some barcodes. Doesn't matter that much. We collect all of this data. It goes into Veriff to something that we call front. From there, it goes into this magic mystery box called like the Veriff decision engine. It's like full of pixie dust and machine learning and matrix multiplications, all of those things. And out of that magic box comes a decision that we send to this bank. Is this person okay or not? Are they trying to perform some fraud, or is this a legit thing? And from there, the bank tells the customer, all okay, you can move forward, you can get on with your day. But always like things aren't that pretty. If things aren't going well, our customer could see something like this. Oh no, system hiccup, apologies, let's try again. And obviously it's bad for us as a business because we have like engineers on call, they get a phone call in the middle of the night, they have to wake up, log onto their machines, start fixing stuff. Our customers are unhappy because their conversion rates are dropping. These critical business functions that they do aren't working. And most important of all, there is this person who is looking at the screen on their mobile phone, and they are trying to do something. They want to log into their work account. They can't. They maybe need to transfer some money to their relatives abroad, and they are stuck. So everybody all around is having a bad day. So to that end, reducing these sorts of incidents is really important for us. Let me take a side trip here as well, how we grew as a company. So today we have around 325 different repositories contributing code to Veriff as a product as a whole. And it's up from around 100 in 2018. Or 2019. It would be even more impressive, but we didn't have data going back to like 2017 or these like very old days. Similarly, we use microservices, and today we have 150 unique services deployed, up from 60 just 3 years ago. And we do about 60 daily deploys to production on average. So every day there are like 60 deploys happening across these 300 plus repositories, across 150 services. So there are so many things that can go wrong there between all of those things. And internally, we have these things that's called in the industry as 5 nines, which is like 5 nines of reliability, 99.999% of uptime. And if you take this from a year, it's just a bit more than 5 minutes. So one side that like any engineer, when they see 5 nines, what they start thinking about is, okay, we need high availability, multiple clusters, we should use multiple availability zone, what if AWS goes down, like all of these things. But at the same time, if a bug hits production, those things are not gonna help you, and you're not gonna fix that bug in 5 minutes usually. So what we want to do is, we want to catch these bugs before they even get there. Before we make this deployment, before we start counting down from that 5 minutes per year. It's not a lot. And I know what you are all thinking here, like you should use unit tests, you should use integration tests, you should do manual testing, you should do contract testing. Like all of those things are awesome, and we do all of these as well. But as you know, unit tests can have like a bit of a downside to them. You're typically testing like one service as a whole, like one window in isolation here. Once you put them all together, turns out it doesn't actually work. So we want to catch these bigger failures where multiple services figure out, like, oh, that actually doesn't work. Or maybe there is a message being passed between 3 different systems, and there is a 4th one listening in that nobody even knew about. We change the format of this message, we go to production, we think everything is good, and then boom, there's an incident again. So we try to do as much testing as we can across all of these layers, but today I'm going to talk about end-to-end testing. So this concept that we take Veriff as a whole, all of these services, and we test it as one piece to discover these integration issues. So if we talk about end-to-end testing as a signal, so let's imagine that our product is a plane that we're flying, and you're in the cockpit of that plane. There are like multiple dials everywhere. You can see like the altitude you're flying at, your airspeed, what's the air pressure, what's your location, I don't know, powers of the engines, all kinds of stuff. And similarly, we have all kinds of metrics about our services. How they are doing in production, how is our code coverage when we are still developing and testing, and so on and so on. And end-to-end, it doesn't give you almost any of that. It's like this one very small dial in the middle of the cockpit that's giving you like one very strong binary signal. Is the plane on fire or not? It doesn't tell you anything about where are we flying in the right direction? Like how is the plane going? It just tells you, is it even on fire? Can we like fly this thing at all? Does it even work? So that's the problems we had and that we decided to solve with end-to-end testing. And before we even got to implementation, we agreed upon a few core principles that this test suite should cover. So let me go over these one by one. And they're in rough order of priority. So first off, this test suite needs to be stable. When we run this test suite, let's say with only production versions, it should always pass. So if it starts failing, and first off, people start distrusting it. It's like, this signal, that dial is going all over the place all the time anyway. Why should we even look at this? So it gets flaky, developers start distrusting it, and at that point, there's really no point for this check. The other side is, it really needs to be fast, because this is on the hot path of any deployment, so it should be at least 15 minutes or less. If it gets longer than that, then the original engineer who is doing the deployment, they don't have time to wait for this. They will go for lunch, for coffee, they will forget about the deployment, it goes live, nobody's monitoring at this point anymore. So it should be as quick as possible, just to reduce the amount of friction that we put on the developers. It should also mirror the most common traffic in production. I gave this old mobile app version before as an example, but let's imagine 80% of our users are using this old mobile app version. We should test on that. There is no value in testing like some latest version that is actually not in production yet, because we are not catching any of these backwards compatibility issues. They could still be happening. And I guess the most controversial one is that the test suite would only exercise the public API and the interaction surface. So the test would be a true black box test. It wouldn't know anything about this magic pixie dust box there. It would just exercise these API front and let's say these phone interfaces as our customers would, as our users would. So if I would put end-to-end as boxes here, end-to-end would be playing the part of the bank, the customer, and end-to-end would be playing the part of the user who is actually doing interactions on that phone. So we have our core principles in place, and it's nice to put them in place. But you need to monitor them as well. How well are we doing with these? So we built a dashboard. We monitor our runtime for all of these. Recently we're doing quite well, so we are fast. We are below that 15-minute mark. We are also monitoring flakiness, so we run this test suite nightly on versions that we think are good, and whenever it fails, it gives us a signal that the test suite itself is bad. So we aren't doing that well there right now. It's like 81%. And we revisit this dashboard every other week just to see how we're doing. And if we have regressions, we can figure out, okay, we probably need to change our course here. We need to do something. Yeah, and we still got a bunch of challenges to go, like this flakiness here. Cool. So that's the very basic idea or the goal, what we wanted to achieve. I'll talk a bit about implementation, and I'll start off with some maths, but I'm not gonna show you any ugly formulas, anything like that. Let's have nice little boxes and shapes. So let's say we have a set of services that we know that work well together. So we have a bunch of microservices here. Some are bigger, some are smaller, some are round. And we already have this set. We can call this production. So if there is a problem in production, then somebody gets a phone call. Then a developer wakes up and they fix it. So we can assume that production at least is always working, or otherwise we don't have a working product, we don't really have a company. And in this nice set of services, let's say we have one specific service that we call maybe core, and it has 3.14 as a version. So what this end-to-end test suite is built to answer is this very simple question. If we replace this version with a newer version, let's say core 3.15, would this cause an incident or not? Would our plane still be running, or would it be on fire? And the easiest way for us to do that is we create this test environment that's very close to production. Like all of these other services, they have the same version. But we take out this core 3.14 that was deployed there, we take 3.15 instead, we put it into this test environment, and now we run our test. So at this point, the only thing, like mathematically assuming that our test suite is 100% deterministic, it always works. The only thing that we changed is this version of this one service. So if this is good to go, we know with some degree we can put this to production. It can still cause an incident. This isn't like a perfect, fully covered test suite by any manner. But if this fails, then we know with a certainty, like, okay, we shouldn't put this into production. This is gonna cause trouble. And if all is good, it goes to production. So it becomes part of this new set of good services. Our production services are updated. A bit of background here as well. I will go very briefly over it, but I hope we're gonna have a chance to do another talk about this because this part of Veriff is really awesome. We deploy things through a tool called Deploy Manager. So anytime there is a build in our CI system, we use Circle CI. It sends a Docker container off to container registry, and it also lets Deploy Manager know this thing has been built. And from there, Deploy Manager knows like, okay, we have these Kubernetes clusters, let's say production and staging, I can deploy there. But there is a third very, very cool option. We have these temporary Kubernetes namespaces called review environments. And I'm not gonna go into too much detail, but the important part here is, this is a copy of Veriff. Like any engineer at Veriff can go into Deploy Manager, just start pressing a few buttons and say like, I want to create a review environment that has default versions from production, and I want to add this service there with this specific version that I want. So very similar to what we wanted for our end-to-end test suite, and we had this already. So we just took these review environments for our test framework. On the other hand, for our mobile SDKs and our web, we were doing UI testing already. So it took some work, but we used the knowledge from that to build that part of the system that would like press these buttons every time. And once we have the test suite, we can move forward to the deploy gates. So we leveraged all of this functionality, and we built this way to build up review environments and start gating the deploys. And let me walk through how that works as well. So first off, there comes an engineer. They say, I want to deploy this core 3.15, push it to production. Deploy Manager would ping this other service called end-to-end orchestrator. And it would ask, is this version any good? End-to-end orchestrator internally would have some sort of queue, let's say a deploy queue, where it starts picking off these services one by one. So currently, core 3.15 is blocked. There's something in the way there. But soon, it would process that one, and then it would get on to core 3.15. Now, end-to-end orchestrator will go back to deploy manager, saying, give me a review environment with production versions, but this core 3.15 in there as well. And deploy manager is very happy to oblige. It will create a new review environment, deploy everything in there, put this new service in there. End-to-end orchestrator will kick off this end-to-end test suite, run all of those things with this new version, and then finally tell deploy manager, yeah, this version is awesome, let's deploy it. And deploy manager will go on to do just that. So let's say things are not that rosy, something goes wrong. In that case, obviously there is no deployment. But at the same time, we also provide some debug data for the developer to see what went wrong. So there's a lot of information here, but the important bit is it's a product called Allure that we are very happy with. And it will give you this drill down option of going into, like seeing the DOM, for instance, or seeing the requests that are made, and see the exact step that failed there. So now we're all good, right? The talk is done. We have built end-to-end test suite. Well, not so fast. So things really work out that easy. While building it, we had a bunch of challenges. So first off, this back and forth that I showed you, with this queue and end-to-end orchestrator. If I lay it all out, it looks something a bit like this. And for us at this point, this complexity with the queue was a bit too much. So sometimes the queue would just get stuck. And that means no deploys whatsoever for any developers until somebody goes and unblocks it. We were also doing this performance hack or optimization where we would reuse review environments, and sometimes some state would get stuck there and it would start failing all of the next builds. So it would again be like a bad time, somebody would need to go in there and fix it, and until then all of these deploy gates were failing. So we decided to do away with the queue, come up with something like much simpler. Deploy manager, it already knows that when it's gonna tell end-to-end orchestrator, like test this, that it's gonna require a review environment, and all of this back and forth was really, really unnecessary. So we ended up with a much simpler solution where deploy manager, when doing a deploy, it will immediately create this and just ask end-to-end orchestrator to test this, and then it will get a reply back whether it's good or not. Now, there is a downside here. As we don't have any queues, then at this point, let's imagine this, I would say unlikely, but this scenario that we have two services getting deployed simultaneously. And if we test one of them in isolation, everything is good. And if we test another one of them in isolation, everything is also good. But there is something in communication between these two services that if we put them into production, then they will cause an incident. And at this point, at our size and the number of deploys we do, we just looked at it and we decided like, this is worth the risk. Our deploy frequency isn't high enough that we can test these things in parallel. We don't need this fully rigid deploy queue. Like we are not Uber or Google or one of those companies yet that need this level of tooling. So we simplified this a lot. Another part, going into this Allure, like this massive page of information, was a bit cumbersome, and it was a bit hard to understand what went wrong there. So we built a tiny Slack bot that would do this for you. It would log into Allure, it would gather all of this data, and just take the most important bits and put this in a Slack message. So when the end-to-end gate did fail, as it sometimes does, you would get a quick overview of which job, which step failed, what were the actions taken just before the failure. We had a few other challenges that I'm gonna go over really, really quickly. So one of them was getting this test suite under 15 minutes. We've been working with end-to-end, I think, for about 2 years, and we got below this magical 15-minute runtime just a few months ago, even though it was the original goal all the time. We had like iOS SDK builds taking too much time, so we actually took them out, and we're planning to put them back in there as long as they're fast. But it's a great example of trade-offs. Like similarly, how I showed before with deploy queue, sometimes you just want to cut this complexity out to get something else for it, for instance, speed. And we had a similar problem here. We also switched our tests over, so this is getting a bit technical, over from Cypress to Playwright, because Playwright is a much faster framework testing. I don't know too much about that, but we have Veriffians somewhere here that do. So if you want to talk about that, go ask him, Bogdan over there. We also had this, or still have, this massive challenge that our data topology or database topology in production is very complex. So we have multiple tiers of databases. They have multiple shards. There's like all crazy replication paths. I think there are only a handful of engineers at Veriff who completely understand it. And in these review environments, we had one puny database. So it's trying to play the roles of all of these. So this would sometimes cause problems because we wouldn't notice failures due to this more complex system in production. And also some of the apps would be untestable. They wouldn't even work in review environments. So this is something we are working on right now to try to bring these two worlds closer. Another huge challenge is service coverage itself. So today, out of these 150 services, roughly 100 are something that we would call critical. 50 are more like, let's say, tooling or something that, well, no service should ever be down, but possibly something when it's down, it's not really causing an incident. But 100 of those would cause an incident if they're down. And today we are using these deploy gates about, let's say, half of those. And it's closely related to this last part, that the data stack between the review environments and our production is so different. Also, local development of this test suite itself is a massive pain. So we don't have a way to do it today. You would make changes to the test suite, run the test suite with a deploy manager, and wait for the reply. Even though it's fast for the gate, it's like 15 minutes, and getting a feedback loop for your deployment of 15 minutes, or like your changes. You make a change, you press run, you wait a few cups of coffee, you come back. That's no way to develop. And today we don't have any way to do this locally. We're thinking of it, but it's a massive pain. And debugging all of these issues in this test suite is still very hard. Because if something goes wrong, it can be in any one of those services that is participating in this test suite. So for us, at least so far, there's pretty much been the case that we need a dedicated person. We have like the point man for this test suite. It started off a bit of a side project between like various people in the developer experience, in the quality engineering team, but it wasn't really like the top of the priority or like full-time job for anyone. So here and there, like balls were dropped. So that's really important, that at least we found for now, with the issues we're having with this, we need a dedicated person. And a few takeaways as well, just not to finish this on a sour note of like all these problems and issues and things. Overall, this test suite is working. Every now and when we do catch issues, and sometimes quite bad issues, before they hit production. And if you build something like this, you should celebrate these. You have spent all of this massive engineering time building a test suite, and it's working. You are avoiding so much pain for the on-call engineers, for the customers, most importantly for the end users who can proceed with their day. And I think even we're probably not celebrating these enough. We should definitely do more. And another takeaway for you, like, should you introduce a test suite like that at your company, at your workplace, when you go back to it tomorrow? Well, it really depends. Like, do you have the right product? Do you have the right amount of people? If you're a team of 5, I would say no. But if you are maybe at our size, or let's say you're Bolt or Wise, I don't know where anyone is here, why not? Especially if you have a product like us, where everything is so transactional. Most of the time, going through the session for the end user takes a couple of minutes at the most. So we have like a very, very clear-cut one single flow that we want to test. Let's say you're Bolt and you're doing ride shares. Similarly, you have a very clear user interaction. They order a taxi, it goes to the driver, sorry, not taxi, a car. The driver drives around them, picks them up, takes them to the destination, you can leave the rating at the end, and boom, done. Like this is their product, it's very transactional, it could work there as well. But let's say you're building an IDE, or let's say you're building GitHub. GitHub doesn't really have this like one core thing that should work. So I imagine if they had an end-to-end test suite, it would probably be massive. So yeah, if you have the right product at a certain size, absolutely. But do plan accordingly as well. This is like an effort in manpower, in complexity, in time, in all of those things. But at the end of the day, it is catching issues, so it can be worth it. Do we have any questions? Do we have a mic as well? Yeah.
Wait a minute to turn on. Yeah.
Okay, yeah. Thanks for the talk. So my question would be, do you have any kind of metrics or KPIs that you use to measure the health of your engineering teams or the code base?
Yes, a lot of them. Not too many in automated wise. And Deet, you will start waving if I talk too much, right? Like anything forbidden. So we have this, I would say like an sort of an audit of the engineering teams and their code bases, which is done manually, and we just grade in all different areas. Like how is your tests? How is your, I don't know, logging? How do you do deployments? What are your development processes like? So that's one side that's done manually. And on the other hand, we have this tool called Service Visibility Tool. So we have really boring and straightforward names here at Veriff. And this tool goes into all of the GitHub repositories, enumerates them, and then collects data from different sources to also get like some measurement into what is this repository doing. Is it like using a late enough version of Node, or is it behind, or stuff like that?
In-house built or?
Yes, at the moment, yes.
Thanks.
Over there, please. You said that debugging is a problem, but why? You can't create a review environment or safe review environment which is broken. I mean, which is green or which is red.
So, yeah, debugging wise, the biggest problem is just if it's the service that is at fault, that's the easy case. So end-to-end is working as it should and it's stopping a bad deployment. But let's say we have a flaky test suite, or like some services sometimes behaving badly. And then we have like all of these microservices where the failure could originate from, and debugging that, going through all of these logs, that's the difficult part. So we need an engineer who is like at least capable of debugging any service that we do, which is a hard ask on anybody. If that answered your question.
But developers can create a review environment for their needs and do checks on some dedicated environment. Yes. What is under your deployer, this manager?
Mm-hmm.
So is it a Helm chart or something like that?
It is also completely in-house. I would say it's something like Helm, but it's a bit more complex. So I would love to talk about this. I could do this for an hour probably, but I hope we will have a talk on Deploy Manager separately. So it's similar to Helm. It's an abstraction layer between our own service manifests and the Kubernetes stuff that is happening.
Thank you for the talk. And what about other type of tests, like unit integration?
We do all of them, even including manual tests. Like a great example is we have Android and iOS SDKs, and there we don't really deploy services, we ship binaries. And with binaries you have this awesome feature that once they're out there and somebody grabs them, you cannot really roll back anymore. They're there, they're live. So for instance, with these very, I would say restrictive environments quality-wise, there we even employ manual testing. But we do unit testing, we do integration testing, all of those other layers of testing. One thing that we don't do today that we have been looking at is doing contract testing, which would definitely be a useful tool as well with that many services. But it also requires this pretty high like upfront investment of actually building out the schemas, the contracts, the tooling around to like enforce them, test them, so on.
Thank you.
Yeah, can you pass it over there? Thanks.
Hi, thank you for the talk. Just a quick question. Is it part of developer team to write those tests, or you have dedicated team? And also, does it include performance testing somehow?
Performance testing is a separate topic. It's using review environments as well, but that's separate from end-to-end testing. Test suite-wise, it's a bit of a shared responsibility right now between a team we have called quality engineering. But ideally, and most of the time, the teams who, how to put this? So let's say I have a very like well-defined product like the SDK, or let's say one of these public APIs that is being hit. Then those teams are expected to own that part of the end-to-end test suite to make sure that is up to date. Because at the end of the day, they are owning their service, they're doing refactorings there, they know when we also need to update the test suite to match that.
Hello. Well, yeah, thank you for a talk. It reminded me a good old days of one of my previous companies. And the question, well, it's strange nobody asked it yet, so it should be me. How much E2E tests do you have? I mean, the usual, the biggest possible test suite size under these 15 minutes.
It is very small right now. Oh, I think we have like 8 sessions going through from various sources. But it's like the test itself, one test case is quite literally end-to-end. So it starts with collecting the data, it goes through our system, all the way to like these decision webhooks that are being sent back to the customer. So that's like one test case. And currently we have like 7 or 8 of these. We definitely plan, yeah?
Sorry, did I get it right? Just 7 E2E tests, yeah?
Yes.
Okay.
That is like covering the whole transaction flow itself. So it's like a one very, more of like a one very wide test that is testing everything instead of like a one test case being very narrow and testing one thing. For these narrow, like let's say more specific use cases, there are better tools for that. It's like integration tests, unit tests, things that are much more easier to debug and where the failures are much more clear.
Yeah, okay, thank you.
Can I
Thank you for your talk. And on the slide where you have like a major box of Veriff, you mentioned also machine learning. How you approach testing machine learning models, because it's kind of not deterministic, so all predictions depends on data which you pass, and kind of if data is updated, prediction is updated. So do you have like a general approach how to test machine learning models?
So first off, like I'm a full-out engineer. Like I write code, I don't train models. Nothing better. It's like awesome that we have people that do. So I don't know too much about this part. It's deterministic enough for the end-to-end test case. But similarly, like somebody asked before performance testing, we also have like a model testing framework built on the review environment and like a similar approach to this that you can deploy specific machine learning models and you can drive like, let's say 1,000 sessions through them or more and like see how everything works, how your model behaves. But it's too much out of my wheelhouse to like give you any more details here.
All right, thanks.
So let's put in one last question, if anyone volunteers here.
Tough luck, I have 4. First question, do you have an exception in your pipeline to avoid waiting for the end-to-end test to complete, just because you have 5 minutes to react to an incident, right? To triage an incident, and you have to wait 13 minutes, so I assume you have some sort of like exception, right? Some sort of avoid function.
The end-to-end test suite goes before the deploy, so we don't even go to production before this 13 minutes is passed.
Yeah, but let's imagine I have to write a hotfix for a production failure.
Okay. Yes. Obviously, there is like a checkbox. You can skip this if you want to.
And how are you making sure that it's not abused, this function, to bypass it?
Like with everything else, we measure it. So we have data and the dashboard where you can see how often it is skipped.
All right. And just out of curiosity, how much time does it take to spin up the review environment?
Bogdan is showing me 4.
4 minutes.
Around 4 minutes.
All right. And my last question is, do you use Allure Enterprise by any chance? Or is it just reporting tool?
It's
Okay.
Okay.
Thank you.
Thank you. And there's actually one last that came in on YouTube by Madis Pink. So how much tests do you have that run under 15 minutes? So it's 7, I guess, right?
Yes, yes, and currently all of them, 100%
Okay.
times it's currently
Okay.
faster.
Cool, cool. Madis, great talk. Thank you so much.
Thank you.
And pizzas are here.